In this video tutorial, we will learn how prognostic definitions in eXpress are used to represent expected prognostic behavior. Prognostic measurements are represented in eXpress in much the same way as diagnostic measurements, that is, using test definitions, the main difference being that special prognostic parameters are added to represent the expected horizon and accuracy of each prognosis. In eXpress, using this sample model of a brake assembly, let's look at how the definition for a standard diagnostic test can be easily converted into a prognostic definition. This model already contains a test that represents the squealing sound made during braking to indicate that the brake pads need to be replaced. This is, of course, a perfect example of a condition-based prognosis, an indication based on measurable characteristics of the system, in this case the amount of wear to a brake pad, that indicates the need for maintenance in order to avoid an impending failure. If we edit this test, we can see that its coverage consists of two failure modes, one for each of the two pads, indicating that the wear is beyond limit. Now for a normal diagnostic test set, all of the features related to prognostics are hidden. To access these features, you must first mark the test set as containing prognoses. This is done using the usage drop box on the test set details panel. Once we have made this change, and notice that the change is at the test set level, not at the test level, then a new prognostic settings panel appears when we edit any of the tests in this test set. On the panel, the analyst can define one or more horizons for the given prognosis, each with its associated accuracy. By default, every prognosis has a horizon of 0 hours and an accuracy of 100. This basically means that, by default, the prognosis will identify the impending failure some unspecified time before it occurs with 100% accuracy. Now, the accuracy has been broken into two different terms, confidence and correctness, that can each be assigned separate values. The confidence is the likelihood that the prognosis of this failure will occur in advance of the actual failure by at least the amount of time specified by the horizon. The correctness, on the other hand, is the likelihood that when a fault is prognosed, then that fault would actually occur during the specified horizon. We'll speak more of this in a minute. For now, let's change the default parameters by clicking on the Edit button. We'll change our horizon from 0 hours to 6 hours. And note that I can enter any units here. I can enter this in terms of minutes or in terms of days or whatever. I'll change my confidence from 100 to 80, and my correctness, this time I'll type it in, I'll enter as 90. Notice that by default, the accuracy is set to the confidence. In eXpress, the accuracy reflects the likelihood that, due to prognostics, a given failure will be repaired prior to that failure actually occurring. In this case, a confidence of 80 means that the failure modes covered by the prognostic measurement will be prognosed 80% of the time and will fall through to failure only 20% of the time. This, of course, assumes that maintenance will indeed be performed any time that this prognosis occurs. If, however, the prognosis must be confirmed before maintenance is performed, then the analyst must enable the checkbox at the bottom of the prognostic settings panel. This checkbox indicates whether or not corrective action should only be performed for prognoses that have been verified as correct. When it is checked, then the accuracy is calculated as the product of the confidence and the correctness, interpreted as percentages. So if for this failure, our squealing brake pads, we were to visually inspect the pads to see whether they've actually worn down or whether we are getting false squeal, then prognostic replacement would only occur 72% of the time. Conversely, this means that 28% of the time, prognostics would potentially continue through to failure. Once again, if this checkbox is disabled, then the correctness is ignored and the accuracy is calculated based solely on the confidence. This means that any time that a prognosis occurs, the appropriate repair would be performed. Now, although for the purpose of early diagnostic engineering analyses it may be desirable to have only a single horizon per prognostic measurement, it is certainly possible to find multiple horizons with different confidence values for the same measurement. We can add an additional horizon by clicking on the Add button. Let's add the horizon of 100 hours, and we'll specify the confidence as 65 and correctness of 100. This is allowed, provided that the confidence goes up as the horizon decreases. In other words, the closer we get to failure, the more confidence we must have in our prognostics. The same rule does not apply to correctness parameter, however. It can be larger or smaller as you get closer to failure. When more than one horizon is defined for a given prognosis, then by default, static analysis within eXpress will utilize the horizon that has been assigned the highest confidence. For simulation-based analysis, on the other hand, all defined horizons may be used to determine the likelihood that a simulated failure would be prognosed at various intervals prior to the point where the failure would occur. This concludes this video introduction to prognostic definitions within eXpress.